A particle P of mass a half kilogram is attached to one end of a light elastic spring of natural length 0.6 meters, modulus of elasticity 60 newtons. So if you take that information and write it down right at the beginning, you're going to be needing it for sure. The other end of the spring is attached to a fixed point A on a smooth horizontal surface on which P rests. So here's my particle P, and I've drawn a diagram with it attached to a spring, and here's my point A. So show that P moves with simple harmonic motion. We'll use this, the particle is held at rest with AP equal to 0.9 meters in a minute. So, simple steps. Got the equation for tension, minus lambda x over L. We've got L, we've got lambda, x is the variable. We set that equal to ma. The mass was given to us in the equation, half a kilogram. And then we can rearrange, and very simply we find that x double dot, or the acceleration, is equal to minus 200x. So this 200 will become our omega squared. But once we've found this, that's the proof that the particle moves with SHM. So that's the first job done. Then the second part is to look at to find the period. So using the fact that omega squared is equal to 200, omega is the root of 200, or 10 root 2. So the period is 2 pi over omega. So substituting our value for omega in, we get root of 2 over 10 multiplied by pi, or pi over 10 root 2. So the amplitude is 0.3 meters, and that's taken from the information given in the question. The particle is held at rest with AP equal to 0.9, and the natural length of the string is 0.6 meters. So 0.9 minus 0.6 gives us 0.3 for our amplitude. Then the final question asks us to find the velocity, or the maximum velocity. So the maximum velocity is where the displacement is 0. So using the equation v squared is equal to omega squared a squared minus x squared, you have that the maximum velocity is just omega squared a squared. We found omega squared before, it was 200. We've got our a squared, well, we've got our a is 0.3, so a squared is 0.09. Put those two together, you get v squared is 18, and v is the root of 18, or 4.24 meters per second. Okay, so that's that question done. Okay, if you need to, look over it again. It's quite a simple one to begin with. So I'll go on to a slightly more complicated question now in this same video. Now this question has some beautiful English in it. It's a smooth cylinder whose axis is horizontal, just meaning the cylinder is laid down flat, as I've drawn here. And there's a piston inside, so the piston has a mass. So essentially you've just got a mass contained in a system, or a mass on a flat surface. And one end of the cylinder has a spring attached to it. So it's just a mass spring system acting horizontally. However, the question is a little bit mean. Okay, you've got to work that out yourself. Information given in the question is the mass of the piston, 2.5 kilograms, modulus of elasticity, 400 newtons, and the natural length, 50 centimeters. So obviously we'll have to use half a meter for that. The piston is held at rest in the cylinder while the spring is compressed to a length of 42 centimeters. So that's going to be a displacement of 0.08. The piston is released, and the spring can be modelled as a light elastic spring, and the piston can be modelled as a particle. Find the period. So we start off with tension is equal to mass times acceleration. We substitute in our values of tension and mass. We find that the tension divided by the mass gives us minus 320x is equal to the acceleration. So that leaves us with omega squared being equal to 320, and omega being equal to 17.9. So as period, I'm using T for period, don't get it mixed up with T for tension up here. The period is 2 pi over omega. We've got 2 pi divided by 17.9, which gives us 0.351 seconds. Quite important to include your units there, even though I haven't, so I'm going to put it in really big there. Seconds, S for seconds. So, B. Find the kinetic energy. Okay, so find the maximum value of the kinetic energy of the piston. Maximum kinetic energy is at maximum velocity where the displacement is 0. So V squared is equal to omega squared A squared minus X squared. X squared is equal to 0, so we just have 320 multiplied by 0.08 squared, which gives us a value of V squared of 2.048. Now I'm not going to square root it because kinetic energy is equal to half mv squared, so I'm going to leave it as its v squared, multiply it by half m, the mass was 2.5, so half m is 1.25, multiply the two values together and you get 2.56 joules, because it's an energy, your unit is in joules. Okay, and that's where it's really important that you convert this amplitude from centimeters into meters, because if it's not in SI units, i.e. meters, you won't get an SI unit answer. And just one more question, just for fun, while we're on it. This bad boy is a bit brutal. Okay, so it's a light elastic string. It's been stretched. It's originally 2.5 meters. Modulus of elasticity 15 newtons. The particle of mass 0.5 kilograms is attached to the string at some point K, which divides the string in the ratio of 2 to 3. So I've got my ratio of 2 to 3 here. I've drawn my string between points A and B. The ends of the string are attached to points A and B, which are 5 meters apart on a smooth horizontal surface. So what I've done here, just to be a little bit crazy, is I've split the string into 1, 1, 1.5, 1.5. And the reason why I've done this is just to show the natural length would have been 1 and 1.5. Okay, so 1 and 1.5. But the string has been extended to 5 meters. Now it'll still be split in the ratio of 2 to 3. So we end up with 2 to 3 for the actual lengths. So we've got an extension of 1 on one side and 1.5 the other. So this particle is at point P, and the particle is pulled aside. Now I set it to the right, you can set it to the left and do exactly the same maths and you get the same result. So don't worry too much about that. Now the tension is TB minus TA. Okay, that gives you the total tension. So this side is biggest, leaving that one positive, and that's equal to mass times acceleration, which is equal to 0.5 x double dot. Okay, so for AP you have extension 1 plus x, so that is the original extension of 1 plus however much it's been extended by. So using that, you can have your tension here of 15, 1 plus x all over 1. Now, if we want to be pedantic, we can put a minus sign in there. So I'll put the minus sign in there for now. For BP, the extension is the original extension of 1.5. Take away x, because obviously the extension is being made less if you move it to the right. And so we have 15, 1.5 minus x all over 1.5. Now that clearly cancels down to give you 10, 1.5 minus x. So I'm going to be pedantic again and put my minuses back into here, but there's so many minuses they're all going to cancel and I'm going to end up not caring. So I didn't put them in originally. So combining the two tensions, we're left with one tension, take away the other tension, is equal to 0.5 x double dot, okay, which gives us minus 25x is equal to 0.5 x double dot, or 0.5a. So the acceleration is equal to minus 50x, so omega squared is equal to 50. So omega is root 50, which is 5 root 2. And then when we find the period, it's root 2 over 5 pi, which was what the question was asking us to find. Part B, very easy. Work out the amplitude. It got displaced by 1 meter, and that answer was given in the question. It says AC is 3 meters. Well, A to P should have been 2 meters. If it's been extended to 3 meters, it's got a displacement of 1 meter, which is the amplitude. Okay, so that question was a little bit harder than any of the others, but hopefully you'll still see where the maths slots in, and you'll be able to work it out. Okay, thank you very much. Hope you've enjoyed, and happy springing about.